All right. Good afternoon, everyone. It is 3 p.m. Eastern, and this is the HamSCI biweekly Zoom meeting. And today we're just going to do some general updates and see how people are doing. So I will go through the list. So my name is Nathaniel, W2NAF, and I've been doing a lot of reading and writing about traveling atmospheric disturbances and like over the past week. So Rob, why don't you go? Rob Robinette, how are you doing today?
I'm fine. You can all hear me, I trust. Can you hear me?
Yes.
Oh,
Go
okay.
ahead.
Yeah. Well, I'm continuing to work on the Whisper work we've been doing. Um, we're we're putting up a high performance SQL server that is a clone of the whispernet.org, and that will be, well, it's still in beta site, but in a week or two, and it'll offer sub-second SQL queries on the WhisperNet database with the Grafana front end. We're publishing I think we're going to present, Gwen is going to present a discussion of the database to the next, there's a Tapper meeting or something I think he's preparing for. So we'll discuss that in some detail and be able to do live presentations. So that's been the major focus of our work and recently. We are also publishing an article kind of derived from what we've done. It'll be in QEX, September, October issue. Gwen and I and Glenn discussing atmospheric noise level measurements derived from the Whisper daemon system, which is stuff I've discussed in the past. So anyway, we should see that article come out if any of you read QEX, and if not, I'm sure we'll be able to make it available elsewhere.
That's very good, Rob. And anyone who's an ARRL member, they get QEX now as part of their membership digitally. So
yes.
Everyone who's an ARRL member who can access it. And we've been able to also post certain QEX articles on the HamSCI website for free download by requesting special permission from the ARRL in the past. So if you wanted that, we could request that and they might grant it to us, and then
Okay, well, let's see it get out there first, and then we can talk about how to make it more widely available.
That sounds great. Dev, would you like to make some comments?
Yeah, thank you so much. We have been trying to implement. Is my voice hard? Are you hearing me, Nathaniel?
We are. It's just a little quiet.
I don't know. Okay. So let me try to talk a little louder, okay? Is this better?
Mm-hmm.
Okay. So we're trying to detect signals, and initially we have set up a USRP device to detect signals of opportunity. Essentially, we're aiming to detect the top ions on the signals. And before we do that, to our software that has been already developed by a scientist who have very name, we thought we would rather check those signals in QESDR, because with QESDR we would have a wave interface of those signals, and we would try to share the IP data of the QESDR and try to detect those signals in QESDR. And once we do that, we'll know the essential parameters that could be fed into the software program, which will automatically perform the job of detecting those signals. So we are in the process, and I think we have hit a snag, and if time permits and if everybody allows me, I would take permission to share the issue here in today's meeting. Thank you.
Thanks a lot, Dev. And going down the list, we have Gary, AF8A.
Yeah, good afternoon, everyone. Let's see, it looks like I'm unmuted. Are you hearing me okay?
Yep, you sound great.
Okay, good. Thank you very much. I'm just basically here to learn and listen. I'm a past attendee of the last couple of HamSCI conferences, and having been a ham for over 40 years, I spent a lot of time using the ionosphere. So maybe at some point in the future, as the project progresses, I'll be able to contribute in some way to the project. I'm a graduate of Case Western Reserve. I still live in the Cleveland area, so I think it'll probably be a natural to help David and Christina and John with their efforts, but we'll just sit back, listen and learn and see how things go.
Thank you very much, Gary. That sounds great. Let's see. Bob Gerzoff, go ahead, AK2Y.
Hi, can you hear me?
Yep.
Okay. This is Bob WK2Y. Forgive the lack of video today. I am sitting in my car in a park. There's some stuff going on at the house, so I had to vacate the premises for a little bit. I am currently playing with WSPR data, finally figured out what I want to do in terms of getting a handle on variability between stations. I'm looking at, because we have so much data, I can actually look at pairs of stations on a given day, on a given mode, within a 15-minute interval, and have sufficient numbers to actually calculate some variability, measures of variability on the signal to noise ratio. So I'm figured out pretty much what I want to do, except for exactly what measure of variability I will use. I'll probably do several. The next hurdle that I will face will be automating the process, and I'll probably, so that I can lean on Nathaniel and company, I'll probably see what I can do within Python or Anaconda, Python within Anaconda. Although I am surprised about the statistical package that I am currently using will handle 3 or 4 million observations at a chunk without any problems. So we'll see how it goes. Go ahead, Nathaniel.
Thanks a lot, Bob. That sounds great. All right, next on the list we have Carl, K9LA.
Okay, hello to everyone. Just came in to listen to see what's going on. That's about it, Nathaniel.
Thanks a lot. That sounds great, Carl. Good to hear you. Next, we have Bill Engelke, AB4EJ.
Thanks, Nathaniel. As some people on the group are already aware of, I've got my Flex Radio interface to the data engine simulator, so I'm simulating what we expect to get from the data engine once Scotty has completed the hardware and we have hardware. And yesterday or the day before, whenever it was, I got it working so that I can copy a couple of channels of FT8 signals, decode that, and I got it working so that I'm uploading it now to PSK Reporter. So you'll start seeing a few signal reports in PSK Reporter that are Tangerine SDR, or that's how they're labeled, as Tangerine SDR generated spots. So I am fighting one little mystery problem. I leave the rig, I say the rig, it's the Flex Radio connected to the simulator, connected to the local host. So I leave all that running overnight. And I found out that after it runs for 6 to 8 hours, the program crashes. And so far I haven't been able to figure out why. I thought maybe it was, due to a socket. Some sockets, if they don't get a signal after a certain amount of time, they will get a signal from the operating system to kill the program, but you can ignore those. But I'm using an asynchronous library, and on the discussion forum on that, they say, well, no, this type of this TCP, this is the communication between main control and the web. That's a Python-based web interface that you use to control the system. Well, I don't think it's related to that. I think what's happening is main control is actually getting halted, and there's so many things coming out to the screen that everything is scrolled off and I can't see what happens. So I just figured out how to allow a terminal in Unix to have an unlimited amount of scroll output. And so we'll run it overnight tonight, and maybe we'll see in the log, figure out why the program halted, or I may have to put in some more debugging stuff to determine that. So that's a little bit of a pain in the neck. I have realized recently that I do need to control probably 3 major channels in the system. One is the spectrum data, which is multiple channels with interleaved IQ data. That's what goes through the ring buffer. We also have it working, but the continuous upload of fire hose data to a server. We have that working. That's not the high performance fire hose. The high performance fire hose is the local host won't even be involved. It'll just tell the data engine to start spitting out full speed data to a given IP address and port. So the institutions that have some fast servers can pick up the data at any speed that the data engine can spit it out without the local host being involved. So there's really 2 flavors of fire hose: the fire hose to a remote server and fire hose to something local on the LAN. So those will work a little bit differently from each other. Let me see what else. I guess that's about it. If I think of anything else, I'll hop in and report that later. But we're making progress. Oh, well, I remember what I wanted to tell you. I've got that. That is one of the channels. Then going to have a separate channel for FT8 and another separate channel for Whisper. I found out I need to keep those at separate ports and separate processes because if you try and put them all together into a single program, the thread handling is not so great inside of Linux. But it does a great job of keeping processes separated from each other. You could even set priorities differently between processes, which you can't do with threads. So anyway, making progress. It's a typical software development thing. 1 step forward and 2 steps back. So back to Net.
Thanks a lot, Bill. That sounds really good. All right. Next up, we have Veronica, KD2UHN.
Hello, everyone. Lately I've been working on making some graphs that show when the KP index is high and how that correlates with the amount of radio spots we're seeing with RBN and WhisperNet data. And then I've just been working on clarifying some things that we see in those graphs. Thank you.
That sounds really good. Excellent, Veronica. Next up, we have Tony Rogers. I think this is Tony's first time joining us. Go ahead, Tony.
Yes, it is. Name's Tony Rogers, 80EN. I'm a PhD student at the University of New Hampshire. And I'm really just getting back into ham radio and all of this ham science after a bunch of years trying to finish up my PhD. I've been following HamSCI for a couple of years now at least, and am really just here to get a finger on the pulse of what you all are doing.
Great. Thank you very much, Tony. Good to have you on. All right, David, 88Y.
Greetings. Nice to see everyone. I'm David. I'm the faculty advisor of the Case Amateur Radio Club at Case Western Reserve University in Cleveland. Since last meeting, I don't have a great deal to report. I'm still coding up the Python version of the Twee and Rosenfield frequency estimation algorithm. And I took a bunch of assignments this morning for math tutorial talks for the TAPR conference. So that's what we're doing. I do wish to advertise the pre-frequency measuring test event tonight. It will be 7 o'clock Eastern time. Check to see how good your skills are at frequency measurement, which is the stuff of our WWV frequency estimation problem. I'll put some information into the chat for folks who are interested.
Great. Thank you very much, David. And let's hear from Dave McGaw, N1HAC.
Hi, everybody, and welcome to Tony. Welcome to the state. I'm up at Dartmouth. And a number of things. Been working on the magnetometer for Tangerine SDR, and then working on a deployable loop antenna that we're hoping to get up into the Arctic this season. And I'm also going to be participating in building some Whisper transmitters with STARS, the New Hampshire SciTech Radio Club, this weekend. And I do have a question regarding Whisper. Is there any database that shows where transmitters are, or do we just get to see what gets spotted from now and then? In particular, I'm interested in knowing if there are 6 and 10 meter transmitters out there, because I've been tracking propagation, shall we say, using FT8 and sideband, but I don't know, are there any Whisper, is there a way of knowing where Whisper transmitters are on those bands?
I can answer that. In fact, you can look for my station, Alpha Delta 8 Yankee. If you go to Whisper Maps, pick the band, and you'll see where all the stations that are logging in are. You'll see me in Northeast Ohio.
Aha. Very good. Looking forward to that.
Not much today.
Well, I've got a lot going on 10, but only local on 6. So I'm curious about that because I've been getting FT8 contacts down Florida, Georgia, all the way over to Illinois.
Yeah, on 6 meters, some days it's astonishing. The whole country lights up, but not much today.
Right, but 10 is alive. 6 is kind of dead. Back to net.
Thank you very much. Mike Neruda, go ahead.
On the conference. Back to you, Nathaniel.
I think you're muted. Why don't you try one more time?
Okay. Any audio now?
Yeah, it sounds good.
Oh, greetings to everyone on the conference. Back to Nathaniel.
Thank you very much. Zach Lefke, KJ4QLP.
There we go. Hello, everybody. I'll keep this short because you guys gave me a lot of time on the last call. So my main focus right now is I'm looking at the active antenna design that I've been working on. I did the quick update that I already fired some stuff out on the list. Is I tried the PGA 103 devices, but for the moment I'm shelving that. Happy to talk about why, but don't want to take up all the call to talk about it right now. So going back to kind of the base design that I presented on and refining that a little bit. I did get a bias T built that's pretty cheap. It's a handful of dollars to get the PCBs manufactured and all of that, and they seem to be performing fine. What I have been doing is trying to figure out how to do time correlation between extraordinary mode and ordinary mode propagation from various emitters. I've got a kind of a working flow graph that does the correlation piece, but I think the part that I'm missing that I really need to think about is the phase alignment and the actual discrimination kind of on the front end with this cross dipole that I'm using. So I've started thinking through and like pencil and paper schematic for doing that tone injection or noise injection to do the phase alignment for usurp devices. It's one of the things we kind of touched on the last call. So I'm basically trying to make a board that I might integrate with the bias Ts so that you can take one of the transmit channels, use that to do kind of a loop back phase calibration of the pair of receive channels, and then turn that off to then go on and execute whatever the science is. So that's the main thing I've been working on. I do have a couple of designs for Whisper transmitters that are based on those Arduino designs out there. And one thing I'll just throw out, it's very early stages, but we have kind of an opportunity or relationship to fly ThinSats. The quick version of ThinSats is they're smaller than a CubeSat, and they deploy at an altitude of about 200 kilometers, which is under the F layer. So I'm cooking up a scheme to maybe try to get some Whisper transmitters in orbit at about a 200 kilometer altitude. But where I'm weak on all of this is the science and why that might matter and why that might be interesting. For me, it's a fun engineering problem to put students on. And yeah, so that's it for me. Back to Nathaniel.
Thank you very much, Zach. That all sounds good. and you might be receiving an email trying to recruit you to give a presentation on your antenna design at the Tapper DCC in September.
Yes, I owe a response to Scotty on that. I'll be following up on. I'm about 30 emails behind because I was in a different place today and haven't been at my computer. So I'm slowly catching up, and basically, yes, I'm on board. But I'll follow up more later.
Yeah, we thought that would be a great presentation for that.
Sure.
Okay, wonderful. Let's see. Why don't we hear from I think Christina. We haven't heard from you yet.
Hey guys, I'm writing papers, doing ray traces, thinking of how to put a talk together for Tapper DCC, pretty much the same as it has been, or at least the same as it was during our WWV Telecon at 10 o'clock this morning, which people are welcome to join if they are so inclined. We have them every week. Back to net.
Thank you very much, Christina. Phil Wilkerson, go ahead.
Hello, everybody. My name is Phillip Hilkerson, KM4LVC. I've been in the HamSCI group for a couple of years now, just reading the emails and keeping up with what's going on. So I haven't been able to attend most of these Zoom meetings for the group, but today I saw that I was able to go and that there was a sort of introduction part. So I am a electrical engineering student at the University of Alabama at Huntsville, and I am the president of the Space Hardware Club at UAH, which includes the K4 UAH Amateur Radio Club at UAH. So glad to meet all of you and hear more about the Tangerine SDR. Thank you.
Thank you very much, Phil. Nice to have you on board. Bill Lyles, NQ6Z.
Greetings all. Well, all I've been doing is busy trying to convert FARLAP to Python. We're hoping to have a September delivery date of that. So that's a lot of code to test and finding lots of spelling errors. So back to net.
That's very encouraging. Have you been doing that all on your own or working with Manny, or has Josh been able to help you?
Josh and Manny.
So you've
Josh,
all been working.
Yeah, we split up the tasks.
Oh, good. That's excellent news. Very, very good. I'm super happy about that, Phil. All right, so working on FARLAP. And Andrew, V51 Yankee Juliet. Would you like to make a few comments?
Hi, Nathaniel. Can you hear me?
Yes, I can.
Okay, greetings. Go.
I was just going to say, I think you're our DX today.
Yeah, greetings to everybody. I'm new on the group. I've been listening with interest for quite a few sessions now. My main focus is on RBN, getting it. I've had one node running for 9 years now, but I'm upgrading it with the emphasis on 6 meters. I need for my DXing all of North America. So I'm setting up, getting that 6 meter node running, and hopefully you'll be able to make some contacts and, get some data for the database. Back to you.
Thank you, Andrew. That is a very worthwhile endeavor. That is excellent. All right. Is there anyone on the list that I missed?
Yeah.
Scotty. Sorry about that. It's so tricky with the Zoom, everything moving
Yeah, I
around.
know. And I checked late, so I figured I was last. Did you get Tom also? I didn't.
Yeah, we got Tom.
Anyway, just working on the data engine, working on the power supply, and dealing with a little bit with John Ackerman on the clock module, trying to figure out what kind of power he might need for current and future uses. And looks like it's modest enough that we can supply him with most of the power. But like Tom does, the things that he needs that are critical for low noise, he's going to have to generate on board. So. And then I did get an email from Bob, so he committed Zach to talk. You probably got that, Zach. No, he said it was you anyway, so we'll look forward to having a talk on your antenna stuff there when you get it done. And he committed to doing a talk himself, so this will be good. He wants to talk about RF machine learning, so it's going to be very interesting. So back to you.
Thank you very much, Scotty. All good news there. Anyone else that I missed? All right, I think we got everyone. Okay, we have time for some open discussion. Well, I guess I'll start. Yeah, go ahead, Bob.
I had a quick question. That WSPR maps, is that associated with a downloadable database?
Yes, it is.
Very good. That's all I wanted to know. Back to net.
So Andrew, V51YJ, so you're just starting to get your 6-meter RBN node going? Are you there, Andrew?
Yeah, can you hear me now?
Yeah.
Yeah, sorry. I've got a node, one red Pateo running on HF bands, and I've got a new one which I'm going to be, should be up and running within a couple of weeks. And that's going to be dedicated to 6 meters. I have two 6-element Yagis, LFAs, which I'm going to, one I'm going to direct towards North America, and one more to the east. So, of course, from a DX point of view, those are the areas that are missing on 6 meters. But I think in combination, they should start providing quite a bit of information on 6-meter propagation from now on as the cycle picks up. So yeah, that's the focus for the next couple of months, to get all that up and running.
That sounds very good. Yeah, good luck with that. Christina, I think you have your hands up.
Yeah, thanks for noticing. I just have a couple of things that I sent in the chat. First to Bill Engelkey regarding getting access to the data storage. If you have time for a Zoom after this to go through it, let me know. Second to Zach, the ThinSat idea is very interesting. And at CASE, we've been trying to sort of slowly put together a small sat program that kind of got derailed when the pandemic hit. But we have a local company we've been working with that's gonna hopefully get some office space on campus and work with students to do projects like that. So I would be really interested in hearing more about it, because that's actually exactly the sort of project that we've been hoping to get our students launching. So maybe we can work together in the future.
Sure, yeah. One of the, I won't take a lot of time here. One thing I'll quickly mention is we have this kind of existing relationship with a group called Virginia Space that kind of manages the launch on an Antares rocket out of Wallops Island. So it's all kind of like a Virginia thing, but what they're looking for is more universities and more students building specifically ThinSats for this weird kind of 200-kilometer altitude. And they're having a problem filling that pipeline because most people want to go higher, right? They don't want that 200-kilometer altitude. So that's one avenue, and we can talk more on that as well.
And one note just for the group on ThinSats, they don't go up for very long. I want to say they're up for maybe, is it like a week or something?
Yeah, if you get 5 days, you're lucky. It's usually like 2 or 3 days they decay.
The aim's been for like a week or so, but I remember when they did the first set of launches, and a group from our ham radio club went to the CubeSat development workshop and picked up a lot of stuff on it there. So I think we've probably met some of the same people in this, but they're an interesting platform, and I think it'd be cool for us to think about experiments we can do with that.
Yep, I agree. Yeah, we can maybe start an email chain or something and swap details and go from there.
Thanks.
Yep.
I think Bob has his hands up.
Indeed, I do. Quick question for you, Nathaniel and Bill. I think it was Bill sent the data dictionary to you, Nathaniel, and one of the things I noticed is that the modes listed, like I've got a mode 0 and a mode 7, if I remember correctly. I wish I was at home, but I don't see them specified in the data dictionary, and I'm just wondering if there's an updated version of that data dictionary, or if there's someplace I could find it.
So I guess that question's for you, Bill. Bob is looking at outputs from your RBN Whisper database.
This Bill?
Yeah, that's right.
Yes.
Yes.
I guess I didn't quite understand the question. What did you say? Ask it again.
You sent to Nathaniel a data dictionary, meaning, you know, it's comma separated values, here's the fields, and then there was the dictionary of what the values within the fields represent. And some of the mode values were, if I remember correctly, 0 and 7, which seemed to have a lot of observations, but the dictionary didn't translate what those particular modes were. And I'm wondering if there's an updated dictionary for that.
This goes back several years.
Yeah.
Here's what I remember about that. Well, I'll have to go back and look at, maybe even look at the code, because if I remember that some of this mode information is stuff that comes from it's in the raw data, and which means we'll have to go back and, are you talking about an RBN particularly?
Here, I have a data file up on the screen here. So was it the RPT mode, Bob?
Yeah. Yes.
So a report mode. So you've got report key, then you have transmitter, receiver, and then RPT underscore mode.
TX report mode.
And we don't need to take time on the call here today. Maybe I'll touch bases with you after the call.
Yeah, these are the.
Yeah, I don't remember what those are. I'd have to go back and actually look at the code.
All right. Or if there's some new data that you think I should probably take a look at instead of this, just let me know.
Anything else?
Oh, just a quick question for David. Were you able to get into that UA box? Because Christina said she couldn't.
I haven't tried, but I don't think that I tried before. Did I tell you that I had, or am I not remembering?
No, I mean, this is just something we set up this morning. So.
Right, but you said that I had tried before. Maybe I misunderstood your email.
No, I don't recall saying that. It doesn't matter. Anyway, Christina said she would like to get together after this Zoom meeting and have another one, see if we can work through it. So.
Okay, thank you.
We can do that.
Any more discussion? Questions? Are you trying to say something, Deb? Yeah, all I hear is static. Deb, I think all we hear is static. Hello? Well, it seems pretty quiet today. We didn't have any presentations prepared, so maybe what I'll do is, I think, so I might close down the more formal part of the telecon for now. I think Dev, if Tom and or Zach might be able to spend a couple minutes looking at Dev's block diagrams, that would be nice, and we could certainly leave the call on for anyone who wants to watch that. But then if Bill and Christina wanted to go off into a separate room and work out those things, I think that might be a really good use of time.
Okay.
Yeah, if you could stick me, Bill, and David in a breakout room, I think that'd be quite helpful.
I can try doing that.
Thank you.
So,
does anybody have any questions about the frequency measuring tests? Anybody care? It's okay if you don't.
You should, though. They're delightful.
David, where can we get info on it? Is there an online? You put the URL up, I think, this morning. Do you have a copy of it again?
Didn't I put it up here also? It's netlogger.
Oh, yeah, I see it.
Org. The protocol is that they check in there about 6:45 Eastern time. Expect key down at 7 on one band and 10 after 7 on the other. They've been running these a little bit shorter than Connie runs the official FMTs. He does 2 minutes key down. They're doing 30 seconds or 1 minute. The one Tuesday is the first one of these I participated in. It got 7 entries, I believe. Connie for the official ones is getting about 120. So your odds are pretty good here.
Okay, I went to the web page. I don't see anything on the FMT.
No, they're a little loose about it. They promised me that they would start copying their emails to the HamSCI reflector. So we should start hearing about it. And if you like the idea of these, they're soliciting the transmitting. I give credit to Connie for a certain kind of ham radio immortality. The term of art appears to be being the con of the evening. So if anybody is interested in doing a precision transmission for a couple of minutes one night, chirp up. Or don't have any chirp.
Yeah, I'm interested in it, but have other plans for tonight. But
well, that's okay.
To get in it on some others. I know this is a practice run.
Yeah, there's a practice FMT and a practice FMT. This is the latter. You have to be pretty into it. What can I tell you?
Oh yeah, I'm gonna get better at it, but probably not this one.
Okay.
So David, again, this page just talks about NetLogger and their nets.
Yes, it lists whatever nets have logged in as active. So check in at 6:45. The protocol for this group is that that's when they check in and report what frequencies to listen for.
Oh, okay. So they report the frequencies on the 20-meter net.
Yes, I think probably they're sticking within a kilohertz of 7065 and 14065. They might do 80 meters tonight as well.
Okay, thanks.
By the way, we're talking 6 meters here, and Dave and I have been talking back and forth, and I just saw Louisiana from New Hampshire on 6 meters.
Oh, let's take a look.
FT8.
I didn't see it.
Yeah, very weak. I wouldn't be able to make the contact, but I see him. KV8S.
I'm updating now. I don't know if in my ham career I've made a contact on 6 meters.
I make lots of them. I like it. 6 meters is magic.
Yeah, you made 20 or 30 QSOs on field day on 6 meters alone.
The most exciting thing in the world is when you do DXing with 6 meters. I mean, real DXing, like contact Japan or Kazakhstan or something. That's rare as hen's teeth, but it can be done.
So I'm looking at the WhisperNet. I don't see any. Oh, I do. In upstate New York, I see one contact going on. Oh, and in Massachusetts, there's a local one. I'm not getting anything today at my station in Northeast Ohio. There's another outside of Atlanta. Okay, more than I was thinking, but they're all short today.
It looks like the WhisperNet could use more stations on 6 meters. Is this something that people would be generally interested in?
Yeah, I've been encouraging the collegiate stations to beacon on 6. University of Michigan did for a short time. It's hard to get people to keep doing it. It does seem like people.
Yeah, I intend to set one up over here near or at Dartmouth, because I really want to encourage people to get beacons going on 6.
And Nathaniel, maybe you can get Scranton to do that. It doesn't take much or an antenna.
Yeah, we'd like to. We're still building up our capabilities, so I think we will. It's absolutely something we want to get to.
Yeah, and you could run unattended beacons there, and it's not really clear that Whisper's a beacon anyway, so it's meet and proper.
Yeah.
Well, there is one thing to be aware of with Whisper on 6 meters. If I recall correctly, Whisper takes 2 minutes per cycle, and one of the problems with 6 meters is very, very common that there'll be a lot of fast fading and QSB so you can't get a signal for 2 minutes without there being enough of a dropout to screw up the contact.
It's repeated 3 times in the 2 minutes, though.
Well, yeah, I mean, when I've studied the data, you see very little in the way of 6 meter traffic on Whisper. I think you'd be better. Well, I've been wishing we could get some FT8 and FT4 beacons going, because the data transfer is a lot quicker, and they also survive low, well, maybe not as low as Whisper, but they also.
Right, that's the trade-off.
Yeah.
Right.
As another naive question for somebody just sort of poking into this, is there more of a need for Whisper beacon transmitters or receivers?
Anything you want to supply. Most stations that transmit also receive, but if all you have is a receiver, put it online.
Cool, thank you guys.
Well, Christina wanted to talk to Bill and Dave. So she suggested I put you guys into a separate breakout room. Are you good with that? Yes.
I'm gonna quickly interject before you do to say I'm very interested in that frequency measurement process, and I am on the invites for the meetings. But unfortunately, I have a time conflict, which is why I haven't been attending. But that should be ending at the end of the summer. So I am very interested in the frequency measurement stuff as well, and want to get into that a lot more, especially with like a GNU radio application that can do that, and all the worries of DVC, actual frequencies versus requested frequencies, blah, blah, blah. So just putting my paw in the air to say that's one thing on my to-do list as well. And I'm sorry I haven't been able to attend those meetings up until this point, but hopefully that'll be changing in the near future.
Zach, if you're going to make some lame excuse, you have something more important to do than squint at a radio dial, then just forget it.
We won't get into that now, my time conflicts that I have. But yeah, no, I am interested.
Tom and Zach, would you mind, would you be able to spend a couple minutes now answering Dev's questions or looking at his block diagram?
Sure.
Okay. Dev, you can go ahead. And people can feel free to watch, or if you want, I can open up a side room for other people to join if they want to have a separate chat. Otherwise, Dev, you can take it away. How's your audio, Dev? Can't hear you. Okay, Dev said he's gonna rejoin. He put that in the chat. So he'll come back in a few minutes, so people can just keep talking if they want to. So while we're waiting, Scotty, how's or is Dev are you back?
Yeah, I'm here.
Okay, Scotty, how's the DCC schedule looking so far?
You know, I don't have any idea. Steve's been doing the whole thing, so I got to get with Steve and see what's happening. Our mission is the ordinary people at Tapper is to go out and beat the bushes and get people to submit requests to Steve.
Yes.
So I haven't gotten a recent report. Usually about every week he goes, because we have a ongoing board meeting that runs all the time. List. So we get updates whenever Steve has time to give us one.
Yeah, that makes sense.
Yeah, last week we had about 50 registrations, so which is pretty good for this early.
That is really good.
Yeah, so that was encouraging. So now we've got to come up with some good content to encourage people to go listen. And that's the problem has always been, seems like we only get the schedule about a week before the event.
Mm-hmm.
And so to try to encourage, especially when it's a live event, that's really hard because you can't really make your reservations, plane reservations and hotel reservations and all that only a week in advance.
Yeah, that's true.
You really got to kind of do it blind and just hope there's good presentations.
Mm-hmm.
And it works much better if you can look at them and say, oh, look, there's ones I'm really interested in, and then you want to sign up.
Yeah.
So I think this has helped us because it's got more people active earlier, I think.
Mm-hmm.
So it'll be interesting to see what, but hopefully we're going to have these conferences every week now instead of every other week.
No, these are every other week.
Every other week. Okay. I was going to say if it was next week, I could have more info for you.
Yeah. Yeah. No.
Now? Hello.
Hello. Hey, Dev.
Yeah. Do you hear me now?
Yeah, you're quiet though.
Okay. Okay. I think this is as best.
Can you move the microphone closer to your mouth?
Hello.
I think it may actually be an issue of having the wrong microphone selected.
Oh, right.
That's possible.
Because that didn't
Linux
change at all. Oh, that is a static.
Yeah, that sounds like a bad electret microphone there.
He's on a Linux desktop.
So am I.
Yeah.
Hey, Deb, do you have two microphones plugged in?
Yeah.
So where's the other one? Try talking into the other one because I don't think that one on your headset is the right one.
So I'm changing those, and I think only one gets selected. Okay. Hello?
Hello?
Yes.
You can also try calling in on your cell phone.
Okay, that's a good idea. Okay. That's the best idea.
Yeah, because that's so muffled it's almost not distinguishable, even with the audio way up.
Sounds like he's sitting on the microphone.
Or if he was on a laptop, I've heard the same thing when it's selected to use the laptop's internal microphone with the lid closed.
Right. I think that might be what's going on.
Yeah.
Need to select the external mic.
But he may have done that and he got the hash, so that might be bad.
Yeah.
Hello?
You're still there, but very weak.
Hello?
Did you try calling in?
That's just static. Wow, that's very strange.
Hmm.
Hello?
that's
much better. Yeah.
That's the phone, okay? So let me start by sharing my screen, okay?
Sounds good.
Sorry about that. So where am I? So I have a USRP Ettus N200 device, which has like antenna as source of signal, that's HF antenna. And we were trying to detect chop signals to receive chop signals through that antenna. But to confirm we are detecting those signals, I fed the very same antenna to a QV SDR. And the wave interface of the QV SDR is here. And let me try to share.
Afirmación tan severa y tan auténtica, porque esto es lo que dice el Partido Comunista. Sí, se denuncian estas cosas. Repito, el cuerpo duele entero y ya, bueno, ya hay que protestar y hay que reclamar y menos mal que ya.
So this is the spectrum like in the QVSDR. Now with GNU radio, I'm trying to see if I have, sorry. So I started with a very simple spectrum analyzer. In this, I have USRP source, and that has a QTGU GUI sync. This I took as an example from the GNU Radio website, and I tried to save the data to an IQ from in a folder. And in next one, I will try to analyze that data and try to see what it reproduces. So before I go to this one, I'll try to look at this one, and I'll try to clear console.
So Dev, while you're pulling this up, a first question that I have on this is what type of daughter card do you have inside the N200? Do you know?
I think I do. That's basic RX.
Basic RX? Okay. The ones that I've been messing with recently are LFRX, and sometimes the antenna port that you select in the UHD source matters. Making sure you have the right one. I'm not sure what's required for the basic RX, but your RX1 might be sufficient.
Yes, I checked. I can show the images. I checked online. Maybe I can show those, okay? And I opened the, give me a second. I opened my installation, and they show, sorry. Give me a second. So I don't know if I can show it clearly enough. Anyways, so this shows the installation. In this, RXA is connected to the. I have connected the HF antenna to RXA. Okay, so I have confirmed in a sense I'm using daughter board with RXA. Okay.
Right. So where I was going with that is, well, actually, maybe I'm getting ahead of myself here, but there's also the sub-device specification part of it, and the LFRX and the basic RX I think are a little bit different than something like a UBX, where it's kind of more straightforward, where you have to be explicit about the sub-device specification and the antenna. But maybe I'm getting ahead of myself. What exactly is the problem you're having? Are you like not able to see the signals that you would have expected to see? That was my assumption, but maybe I'm wrong about that.
Thank you. Thank you. You are bringing up the question I thought I would be able to ignore, and I have not devoted as much time as what you are talking on. So you are talking about specifying the antenna, right?
Right, like in that UHD block that you have in the flow graph in front of us.
Oh, which I do, I think.
Well, so what I'm saying is, see where it says MB0.
So this is, give me a second. So this is antenna where I say receiver 1, RX1.
Right, but go back to general and see further down where it says MB0 sub-device spec. Sometimes you have to feed it information in there as well in order for it to pick the right port.
Oh, okay. What do I need to fit here?
That's where my memory is going to fail us on this. It's either going to be like A or AB, or sometimes like A:A. It gets a little confusing, but that is where the actually here I'll drop it into the chat.
Hold on. I might have something to help myself on that. Okay. Give me a second.
I'm gonna drop something in the chat here for you though.
Yeah, but I think I might have something to look.
It might be the same page.
Yeah.
So just as a quick update and a time check, I'm good to go until about 5 p.m. At 5, so I have about an hour that I can play with this. But at 5, I do have another call that I have to get on.
Okay, I think by that should be enough. Okay. So let me try to get the call.
Yeah, Deb. While you're looking that up, there's a couple inconsistencies in the flow graph between the sample rate and the bandwidth that may need to be adjusted.
Give me a second, okay?
Okay.
I can handle one at a time. I'm trying to look at an email that I sent to Nathaniel in which I talk about what you are referring to, like specifying the
Yeah, it can be confusing with Ettus products, and not all daughter boards are created equal, and not all usurps are created equal. So it's really weird.
Here,
sometimes tweaks you have to find.
So we have So our daughter board is basic RX, and the antenna could have, as we see in this link, antenna mode A, antenna mode B, antenna mode AB, antenna mode BA.
Right.
So
what I think you're going to want is that, and see how in the code there it had sub-device and then it had A:1. If you go back to that link in the code.
I'm going back. Thank you so much. I'm glad we talked about this. Otherwise, we would have been beating around the bush. Okay. So over here, right?
Yeah. So see how it says A:1? That is the text that you need to, I think, copy and paste into that not the whole thing, just the A:1.
Okay.
And then copy that into that UHD where it says sub-device spec.
Here,
right there. Yeah. And this might cry, it might not work exactly the first time, but go ahead and give that a shot and see if anything looks different in the spectrum.
So how about the stream argument?
You shouldn't have to mess with that.
Say it again?
You shouldn't have to change anything there.
There's nothing in there.
What's that?
There is nothing in there.
Yeah, that's fine. Usually, most of those things, other than the device address, you can leave as default, and it should work fine for you.
Okay.
Those kind of the top section of that UHD source have to do with the like Vita 49 formats that they're using. So unless you really know what you're doing down in the weeds, you usually don't have to change those.
So, but before I execute this flow graph in GNU, okay.
One thing I would recommend too is just to test it, you can hit, if you click on the file sync and hit the D on your keyboard, it'll disable the file sync so that you're not generating IQ that you don't need, right, without deleting anything. If you just hit D, it disables it.
So D, I have to hit D?
Yes.
Yep, just D. There you go.
Okay.
And then that way you don't have to like delete it and bring it back and all that kind of stuff.
Okay, that's good. That's a good trick.
Yeah, there's another one that's B for bypass, which is super handy, but that's a detail for later.
Okay, thank you so much.
Yeah.
So, but let me ask you something, okay? So I will ask it, okay, before we do this, because
yeah.
So this is, I am probing the device, okay? This is a very commonly used suggested command to check the N200 N-series installation of N-series device, okay? And it is good that I'm getting this output. And it is good, it is saying motherboard is this, hardware is this, blah, blah.
Right.
But it does not say anything antenna, okay, right here.
Right.
It does not.
This is one of the weirdnesses of the basic RX and the LFRXs compared to all of their other daughter boards, because these are basically direct sampling interfaces to the ADC. There's no like local oscillator and things like that. One other thing that you can try, since you have the terminal up, go ahead and just do, I'm going to read it out to you. Have you ever used the UHD FFT utility?
I have, and I failed because after this, like if I have the command, yeah, I think right here.
It's just UHD underscore FFT.
Yeah. So
and then that was it.
Okay, like, give me a second, okay?
Okay, go for it.
USD USRP probe, the command that I gave in right now. So this example shows right here the antenna have a name, right? Output antenna.
Right, but the daughter board is also a WBX.
Yeah.
Which has a down conversion stage on it, which is a little bit different design than the basic RX.
So I should not be worried much about it. That's what I wanted to ask. Okay, should I be worried much about it, or I should not be worried about it?
I can't remember. That's why I'm trying to get you to run the UHD FFT application, because it will specifically tell you which one it's using.
So just this?
Yep. You'll have to feed it a frequency. So you'll do UHD FFT and then -F and then like 12.5 E6. Okay, so you got to feed it the argument to find the IP address of the usurp. So if you go back to that web page, it has the syntax for the argument. See how it has args, adder, equals, blah, blah, blah? Yeah.
So you are suggesting me to give this?
Yep, you'll still need the -F.
And that as well.
Right. And then whatever your IP address is for the usurp, you'll have to update it for that. Oh, no. Do the -F after the address. Yeah.
And IP address of whose?
Yeah, that'll have to be whatever the result was from UHD USRP probe. Will tell you what the IP is.
It was right here.
Yeah,
This
10,
one.
51, yep. No, just change what they have for the address.
Say it again.
Where they have 192.168.10.2.
I got it.
Oh, I see. I see what you're doing.
Because it doesn't allow me to copy it there. Okay.
Gotcha. So I know, not to confuse you, but with the LFRX, the antenna selection does matter because they have the A and the B port.
So I'm good. I'm good to go here.
Yep. Yeah, go ahead and fire that up. You should, assuming nothing else breaks. There we go.
I think we're good. Oh wow.
Yeah. Okay. So if you scroll down on the kind of in the bottom right, yeah, or if you expand it, yeah.
You make me feel very good. Okay.
There you go.
Sorry.
See where it says basic RX AB, and then it has A:AB. Go back to full screen.
On this image, right? USD FFT?
Yep. See, just under the FFT, see where it says A:AB?
Oh, hold on. I'm getting confused. Where are we?
So, see where it says frequency megahertz? Just underneath that, there's text that says device information. So it's saying it's basic. Yep. Ah, thank you for whoever did that. So that A:AB
should go there.
That's what you want in that sub-device specification, not the A:1. And we might have to play around with that a little bit. It could be A:AB, A:1. What I would recommend you do is, do that. And then in the RF options, where you specify the antenna, just delete it. Just leave that empty.
I can't. I have to choose one.
Yeah, you can. Click inside the, click on it. Now just delete. And then apply. Yeah, they don't put that in their manuals anywhere. So try running that and see if it presents you with spectrum. You'll have to close the UHD FFT window.
Wow, it makes me feel very good. Okay, because I went through a good deal of trouble not to be able to configure the antenna through this FFT command. Okay, because when I initially installed, I had good success with the USRP probe command, but not with this command. Thank you so much.
No problem.
Okay. Okay, now we will go here. I will clear the console. I'll try to run this, right?
Yep. Yeah, if you...
there is one more error that I will look at suggestion for, like which I may or I may not.
There's a couple of other things that we'll do, but let's just see if we get some spectrum out of this, if it's picking the right antenna. Well, it looks...
Okay, Dev, one thing, you have a mismatch between the sample rate and the bandwidth parameters.
Yeah.
Where? In the flow graph. Okay, so you have the sample rate at 2.5 megasamples per second, but you have the bandwidth as 25 megahertz. And you only get 2.5 megahertz bandwidth out of an IQ receiver when you have the sample rate set for 2.5 megahertz. So there is no 25 megahertz to display.
So what should I change this to?
Okay, so go ahead.
Go ahead.
So you have.
Okay. Well, what I normally do for that is let it default. So if you go back into your UHD source and just delete that channel bandwidth, not the sample rate, the UHD source, go into RF options, and where you have 25E6 for channel bandwidth, just leave that blank. Or you might have to put a 0 in there. Actually, yeah, you have to put a 0 in there. And that will tell it to basically just listen to the sample rate for the bandwidth to output.
Yeah, the second thing is on the QT GUI sync, you have the bandwidth also at 25. And what you can change that bandwidth from 25E6 to SAMP_RATE. Okay, that will make the bandwidth equal to your variable sample rate. Yes.
But what was the scientific reason on that? That was too fast.
You only have a bandwidth of 2.5 megahertz when the sample rate is 2.5 megasamples per second. There is no more bandwidth than the sample rate. So when you tell it something else, it's
so if I want a bandwidth of 25 megahertz, I have to change the sample rate to 25 megahertz.
That is correct.
So why don't
I'll go ahead and warn you, if you do that with an N210, you might run into drop samples, because that'll be stressing the 1 gigabit per second connection to the N210.
Okay.
Or N200.
Okay, it is N200. Okay. So let's try that. Okay. So due to that caveat, let's do this, right?
Yeah.
Sure. Go for it.
Okay, now just go ahead. Yeah, you can click the green arrow there. Yeah, and that'll just that'll compile and run.
So it's just 2.5, okay? Yeah.
Yes. So you see it's labeled the axes now correctly.
Yeah. Yeah.
So I guess that's the part that I'm not sure if, are we looking at what you consider a good spectrum here? Is this what you expect to see?
That's what I've been trying to verify, okay? So let's go to 12.5 here. Okay?
Oh, I see. So you're using somebody else's Kiwi SDR as like a reference?
Yeah, if our is Kiwi, that's connected right here to the same antenna.
Yeah, we have it. We have one antenna feeding a 3 dB splitter, and then one side.
Oh.
Yeah, actually.
I got you.
Yeah.
Okay, so I think, yeah, on the Kiwi, you want to zoom in to the same frequency range that you're running your GNU radio on.
That's what I'm
look
trying
the
to do.
All right.
Yeah, that looks about right.
Okay.
So the other thing we can try.
11 to 14, okay? Is it 11 to?
Yeah, so yeah, 12.5 plus or minus 1.25.
Looks about right.
It kind of looks similar. So you see at 12.0, you see two carriers to the left and one just to the right.
Yeah.
That same thing.
Thank you so much. Yeah, thank you so much. I was trying to get similar, and earlier with my specification, it was not looking similar. Now it does, okay?
Okay.
Yep.
Now it does. Now visually, I can get my first sight without any scientific information. I can say, okay, it looks similar, which it was not with my parameters that I have selected not correctly, as we found out.
Yeah.
So the next question on this part is, now I'm not happy with just 2.5 or 4 megahertz of bandwidth, okay? I want at least 10 megahertz of bandwidth, because I aim to detect top signals which I'm not sure would be limited to this just 2.5 megahertz. Does it make sense?
Yeah, so if you want to widen up your bandwidth, the first thing is that sample rate parameter, samp rate. That would be, like Tom was saying, the first thing to do would be to change that to say 10 megahertz.
Uh-huh.
And that's one GNU radio lesson to definitely remember. Try to use variables as much as you can, right? Which Tom had you do when he had you update the bandwidth on the Qt GUI sync. It automatically propagated because you used samp rate and didn't manually type in 2.5. It'll show up. So now when you run it, it should work. And you'll see everything kind of scaled properly, but now 10 megahertz of spectrum instead of 2.5 megahertz of spectrum. Yeah.
So this is good. This is good. Okay, I started at 7.5. Maybe I would go like for 12 megahertz, 13 megahertz. Then I'll start with 5, 6 megahertz. And I think that's a good bandwidth to look at, to detect signals which might have come through the ionosphere. Okay.
Sure. One thing you might want to go ahead and do, let's intentionally break something.
So
that
give me one more second. Let's compare and let's see if it is. So at 10 megahertz, yeah. So there is a lot of noise right here around.
Yeah, that looks like WWV that you're seeing.
Yeah, very similar. Okay. So it gives me very good confidence that we're on same page. Okay. Both of them are on same page, which they should be.
So one thing I would recommend you try to do.
Let me look at 16 megahertz.
Yeah, it looks like there's something strong there too. Yep.
Yeah, right here.
Yep.
So yeah. So
or just under 15.
This makes me feel better, feel much better. Okay.
Cool.
Very good. This makes me feel very good.
So I think a good thing for you to do.
So right now we're not seeing any oblique signals, but sometimes I do see oblique signals here in this QE SDR display. Okay. Sometimes I see oblique signals here. Okay. And when I would be seeing oblique signal here, I might be seeing oblique signal here. And when I set the data here, and from the FEB data, I would be able to find the time of those oblique signals, from which I would be able to decipher the start time of those oblique signals. Okay. And that's what I'm looking for.
So you now that you've told me your whole project, you've made me want to tell you about something else, but I'll put a pin in that for a moment. The first thing that I think it'd be good for you to see is if you go back to your flow graph, just try doing 25 megahertz.
In the sample rate?
Yeah, go ahead and do that because I want you to see what it looks like when it breaks, basically. And it won't be a complete crash when we do this.
So you want me to fail? Okay, let's try.
Go ahead and fire it up. And then what we'll do is keep an eye down in the bottom left of the GRC window. And actually it's keeping up. You're doing all right. So you have a good network connection right now. So, okay, we weren't able to break it. What I was trying to do was show you if you were dropping samples, if you were saturating the gigabit Ethernet link, what you would see in that, right where it says like info USRP2 setting references to internal GPSPO, it would start streaming a bunch of O's. It would say O, like the character capital O, Oscar.
Yeah, I have seen those. I have seen those cases. Okay, I have seen those cases, but I did not have understood those. Okay.
Right, and what that is it's saying there's an overflow. So if you're trying to do and what that ultimately means, if you're recording IQ samples, it means you're going to have gaps in the data, right? And you're not going to know where those gaps are and like how many like samples were actually dropped in the recording, right? So that's something to pay attention to and watch out for. But in this case, it actually looks like you're doing fine. And you're keeping up with the, you are not saturating that link, which is good.
Okay.
So you can reliably ingest 25 megahertz.
Next time, let me see. Okay, I can write this IQ data, and from here I can get the IQ data, and these IQ data will be saved. Okay. Yeah.
So okay, before you click off that, go back to that last flow graph where you do the playback. I think it was USRP1 IQ, the next flow graph over.
Yeah.
So for this one, a warning for you, when you hit go on this, what's going to happen is GNU Radio, the operating system and the scheduler are going to try to read in the entire file source and immediately stream all that data into your Qt GUI sync. Right? So it's not going to look right. So what you need, you're missing a block in the middle. It's called the throttle block.
Thank you. I have seen it somewhere. Okay.
And so what that will do is it'll slow the scheduler down. And if you match that sample rate, so if you record at 25 megahertz or 25 megasamples per second, then you're going to want to play back at 25 megasamples per second to be, quote, real time. Right? If you were to play back at half that rate, it would look a lot slower. Right?
Like this, right?
Yep.
Yeah. Now again, you're going to need to adjust your sample rate because the throttle thinks it's 2.5 meg, and your receiver thinks it's 25.
So I should have the same sample rate here as in this, right? My initial, yeah. So
to get a quote real-time playback, you can speed it up or slow it down within the limits of your processor, right? So if you did like say 50 megahertz for the playback instead of 25, if you did sample rate times 2, that will play it back, but it will play it back twice as fast as true actual real-time, right? If you left it at 2.5, it'll play that back, but it'll be 1/10 of the recorded speed, so it'll look a lot slower on the spectrum display. And the only limit with that in terms of speeding it up is your RAM and your processor speeds, right? Those are the only things that'll kind of slow you down or cap your performance.
Okay. So where's
So one other thing that I'll mention, and I'll just, as far as I'll go with this, is I'll just drop a link for you. Is the further you fall down this rabbit hole, because I'm saying all this because probably 80% of what I do for my funded research I call signal collection, and it's all about metadata and keeping track of all these little details, right? Like what antenna did you use, what sample rate were you recording at, what was the data format, blah, 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 blah. And I know Phil Erickson has a different sort of recommendation for this. I think both are good options, but the one I'm going to drop into the chat is the one that I use. It's called SIGMF, and it's the signal metadata format. And what that does is, compared to that file sync that you're using, all that's doing is recording the raw IQ and no metadata, right? So if in a week you come back and look at that data and you go, wait, did I record at 2.5? Did I record at 25? What frequency was I tuned to? All that kind of detail that you might forget if you're not writing that down somewhere and associating that with the file names that you're recording. SIGMF kind of automates that for you, right? So if you use a SIGMF sync instead of a file sync, it will automatically record the center frequency, the sample rate format, yada, 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 right? All that kind of detail. I will say though, getting the SIGMF installed is a little tricky. But I can, if we maybe over email or something like that, I can shoot you pointers if you want to use that. That's maybe a down the road problem now, though, because now you've got enough to get, kind of keep moving with your project.
Yeah, I think I'd recommend using digital RF if possible, mostly because the rest of the project is also using digital RF.
Sure. Yeah. That's that other one. I'm just less familiar with it. That's why I haven't used it yet. That's what I meant by the one that Phil Erickson would recommend.
Okay.
I don't know though if he has, the way I use SIGMF and the reason I like it is that it's natively supported in GRC. I don't know if the digital one that Phil has, if there's actual blocks that you can drop into GRC, or if you're expected to just hit go on an application.
No, there are blocks. There are digital RF blocks. I've
Cool.
used them, and yeah, we've used them before. But I have heard of SIGMF, but I haven't used it, so I have less familiarity with it.
Yeah, it's the only reason I like it is it's kind of the one that the GNU Radio community prefers and uses, right, pretty regularly. But
okay.
Yeah, either are an option.
Yeah, and I mean, certainly for what you're doing right now, Dev, yeah, either could make sense. It's just, in terms of consistency with the rest of the Personal Space Weather Station project, everyone else is using digital RF right now.
Sounds like I need to learn how to use digital RF.
Okay. So maybe I'm ready to go, right?
Probably, yeah. One other maybe warning that I'll have for you is at 25 megasamples per second, realize that each sample that you're writing to a file with the current format that you're using is going to be 64 bits, right? So when you 64 bits times 25 million per second, that's going to rapidly fill up. You're going to generate gigabytes and gigabytes and gigabytes of data in seconds. So there are a few tricks that you can do associated with that, like changing up the file format that it's recording in, right? That blue, all the blue in your flow graph is indicating. Actually, if you could do me a favor real quick, if you could click on the help in the top of GRC, and then do types. So there's the color code for the data types that they use in GNU Radio, right? So you're right now, your flow graphs are using complex float 32. And the complex means that for every one sample, there's an I and a Q. And each I and each Q is 32 bits, right? But the ADC is no better than, say, 14 bits. So you could record as a complex integer 16 and massively reduce the recording bandwidth that you need, right? So
how do I do that?
there are stream converters in GNU Radio that you can use. There's if you look on the blocks in the libraries there on the right, just type like complex. Type the word complex or stream. That might work. Yeah. So complex to I think I short is what you're looking for. Yeah, there you go.
Where do I keep it here?
You don't have to actually feed it anything. You just need to change the file format on the sinks, right? So
on what? Like
on your well, we might be falling down a rabbit hole here. This is where things can get really complicated in terms of the flow graph. So like you could put that stream converter in this flow graph and then change your file sync type to from complex to I short. Right. So like if you go back to your other flow graph.
Yeah, right here.
Yeah. So between your USRP source and your file sync.
Mm-hmm.
Actually, just double click on your file sync real quick. So see where it has input type complex.
Mm-hmm.
Click on that, and see how it has short as an option.
Mm-hmm.
Click on that, and then click OK, and that should change it to the yellow. Yeah.
Yeah.
So you could put that block, that stream converter block, in between, right? And it'll convert from the complex float 32 to complex integer 16.
So I should keep that where? Where should I keep this?
So you could put it like basically break the line between USRP, so go from the source to the stream converter. Yep, and then out into the file. And then you'll have to delete the other line that's already, yep. And then now when you re-enable the file sync, everything should play properly. There's some devil in the detail here that I'm skipping over, like the float to integer formatting. That'll change your relative scaling, but that should work for you. I hope I'm not lying to you right here and confusing you. I think I'm on it. I think this is correct.
So this will save me to this ISOT type, which will reduce my memory. But here I have again blue. How do I change it? Yeah.
Same way. If you double click on it, there you go. Where it says complex, you can change it to short. And then there's another type converter. So that throttle, same thing. You can change that to short data type. And then there's another stream converter that's I short to complex, right? So it was still in there. Yep, right there. I short to complex. So this goes the other way, right, and converts back into a complex format. So you could put that after the throttle and before your GUI sync.
Yes. So Deb, if you'll notice that you can always tie ports.
So I don't need this, right? I don't need this here, right?
You can tie ports.
Oh yeah, you can delete that one. Sorry, go ahead, Tom.
You can tie ports that are the same color together. If two ports are a different color, you'll get an error if you try to wire them together.
Right. So
one more time, please.
Okay, see how when you, the color of the port tells you the format type. And so if you tie two ports together and the ports are the same color, that's okay because they're the same format. If you try to tie two ports together that are different colors, it won't let you. It'll give you an error because they're incompatible formats. Does that make sense?
We don't have it here. We have only LO to LO, L to LO, and blue to blue, right? So we are
Yes,
good.
right. And so you have no errors. Everything is okay.
Let me check here. Yeah, this looks good too. Yeah.
Yep.
Okay.
And so one thing that you'll run into, and there's a way to adjust this that I'd have to play around with, is if you do it this way, when you look at the Qt GUI sync on this flow graph during the playback, one of the things that happens under the hood here is you're going from fundamentally a float object to an integer object, right? And so because of that, there's kind of a change in the dynamic range, which you're not losing any content because ultimately your ADC is less than 16 bits, but it will scale the plot, right? So the plot that you look at on this display might look a lot different, right? Where you're used to maybe seeing a noise floor of like -120 or something like that when you look on the FFT, that might start at like 0. So rather than going from like -120 to, you know, -80 or something like that for the range that you're looking at, it might shift everything up to where you're going from like 0 to +40, right? So just be aware that scaling thing might be occurring there, and that might make the data look different than you're expecting. But there's no loss of information when you do it this way. It's just the way that it's represented.
Let me try to run it. Let me see how does it look like. So this is one more error that I have been, okay. So when I run this green, like when I press this green for the first time, like it says no devices found for this, okay. And if I run it again, like it generally finds it, okay. So I will do it twice.
So yeah, that's not that doesn't surprise me, but I'm not sure I can tell you exactly why that's happening. It's probably that something did not terminate properly, right? So like when you stop this flow graph, try to always use the X in the top right of the, no, not that one, the other one, on the actual flow graph that's running.
This one?
Right, where your spectrum display is.
This one?
No. Where it says top lock and the waterfall display. Yeah, that one.
Here.
Try to use that one whenever you can, because that should gracefully shut down all the sockets and all that kind of stuff. If you use the red X that's on GRC, that's like sending a kill all signal that can sometimes leave hanging threads and things like that, which can screw up the network socket. So I think what's happening is basically it's not gracefully shutting down. You're going to reconnect, but there's already a socket open or there's already something running that never got shut down properly. That fails, which kind of resets everything so that the second time you run, everything gets set back up. It's not dissimilar to what Bill was talking about earlier in the call about the flex radio and kind of the socket interfaces there. It's probably something similar that's giving him an issue.
Okay. So this should allow me to save the data and try to look for signals in the data, right? So for now, maybe I have a good point to start, right?
Sure. And feel free to experiment with that file storing thing. My whole showing you that complex to short, you know, if you think that's screwing you up, then go back to the way you were doing it before, with just the complex file sync, and maybe reduce the bandwidth a little bit. And then if you want help on how to make it play right with the reduced data type, I've had to collect radar signals that are very wide band and I've run into this similar issue where like I just can't keep up with the collection requirements. So this iShort trick is one way to do it.
Okay.
You can actually back propagate that all the way into the USRP source if you want, but that's a kind of advanced application that you probably don't want to mess with right now. But we can talk about that more in the future if it becomes an issue for you guys.
Okay. Okay. And if I have any questions, I'll contact you. Okay.
Yep. Sounds good.
I'll contact Jack and Tom. Okay.
Sounds good.
Thank you so much. I very much appreciate it. Okay. Like I was literally stuck in it because I had no pre-experience, and there was no way like I could have likely identified so many things in such a short time. Okay. That's where experience comes handy.
Yeah. Yeah. The more you screw up, if somebody takes the time to learn from the screw ups, that helps others, right? Get through the gotchas. I call them the gotchas of GNU Radio, and it happens all the time with students, right? Their tutorials are not perfect, but then again, very few tutorials are perfect. So it takes time to just learn it. You'll get it though. The more you play with it, the more you'll learn it.
So I can't thank you enough this afternoon. Okay?
Sure. Nathaniel, is this the same project we were talking about at the beginning of the call with like building an AM receiver and all that kind of stuff?
Yeah. Yes, it's exactly the same thing.
Yeah.
Okay.
I could show like other. So I found few other GRC files online which were trying to detect the AM receiver signals. Okay. Okay.
Yeah.
But this is my initial one, and I thought I should be playing with the simplest one to begin with, where I just detect the signal and then and try to set that in the data and try to again make the waterfall plot of the data and try to see the signature that I am wishing to see. So I was with the most simplest one of these GRC files, but others also are trying to receive the AM signals, and they have more these fancy blocks, rational resampler, or in one of those frequency accelerating FIR filters, AM demodulation, AGC2. So I don't know the details. So I think I should right now stick with the simplest one, and I feel glad that I see the general features of the signals that's being received by this antenna.
Yeah, and that's a great sort of mentality, right? Crawl, walk, run. Start with the simple, and then start adding layers of complexity.
Yeah.
And because like just going back to that other flow graph that you showed, right? Like all the changes we made in UHD, you'd have to make sure you make all those changes there too, right? Yeah, like for this guy, like the bandwidth setting and the sample rate settings and all that kind of stuff. You'd have to make sure you go through and fix each one.
Now, if I get the information that I need to get from the simpler approach, I may not need to go for a complex approach, because the goal of my project is not like playing with GNU Radio. The goal of my approach is to like get the data. And
right, just collection capability.
Yeah, I'm just using GNU Radio to conform and to get started to collect the data. Okay?
I gotcha. Yeah, it's been a while since I've done this, but I think there are actual like Matlab converters that are built into GNU Radio. So there might be like if you did like UHD _ tab, or no, it might be GR _ tab, something like that, would show you all the built-in utilities that they have. And I think one of them is a Matlab converter to move the IQ file into like a .m file. Yeah. So for example, if you're using Matlab, it would put that into the native complex data type that Matlab already uses. So that you don't have to work through all that little endian, big endian, 32 bits here, 16 bits there, all that kind of stuff. I think they have those utilities built into GNU Radio.
Okay. Thank you so much.
So if you are interested, I'm going to drop one more link in the chat.
Definitely.
There's I have this link that I'm about to drop is comes with the caveat of fair warning that this is a personal repo of mine that I use to just stash all of my flow graphs. So no guarantee that any of them will actually work. but I have a folder on here that, here, let me just do it. There you go. So FlowGraph Sandbox, there's an HF folder that has examples of single sideband and AM decoders, and it has like selector switches and all that kind of stuff to tune around in.
Okay.
I'll go ahead and warn you right away that I'm using something called GR Phosphor for the spectrum display, which is an out-of-tree module for GNU Radio. So if you try to execute some of those flow graphs as is, one, the IP address for the user is different, so that'll fail. But two, the GR Phosphor blocks will probably show up as red boxes if you don't have those in your, if you don't have that out-of-tree module installed. Which that should be okay. You can just delete those blocks. That's just a spectrum display feature.
Okay. So David is asking, can I invert the waterfall flow? How can I invert the waterfall flow?
I don't think you can. I don't think that's a native feature of GNU Radio. And when I was talking about GR Phosphor, they do it the other way. So it's really annoying when you have the waterfall flowing in one direction on a real-time spectrum analyzer, and the waterfall flowing in the other direction on this sort of spectrum analyzer or waterfall display, spectrogram display. I don't think there is a native feature to just flip the direction of flow.
So this is showing 20 seconds, right? Is this not the real time?
I've never trusted the time scale there. Part of that is linked if you, so I think you're using the, can you go back to your flow graph real quick? Yeah, so you're using the Qt GUI sync. And part of it is, I think, linked to that update rate parameter. Right, so you've got a factor of 10 in there, and I can't remember the direction of scaling. Normally what I would do is have like 0.01 to make it update really fast, right? To get like a kind of a, not necessarily quite real time, but just go ahead and try it. Just do 0.1 for now. And then just rerun the flow graph and see if that makes it go faster. You can, yeah. I'd be lying to you here. Is it gonna work or is it gonna fail? Did I kill it? Did I break it?
Yes, very slow.
Okay, yeah. So these are those. It went the other way. It added another order of magnitude here. So just so you're aware, you're using the Qt. So try going the other way. You had, I think, 10 originally in there. Try doing 100. And all you have to do, by the way, you don't have to clear everything. All you have to do is just hit that green arrow, and it'll go. Yeah. Yeah, there you go. There it is. So it's a lot faster to display. Now the scaling has changed on the side there.
Yes, it is 200 seconds, okay?
That's 2 seconds. E to the 0. Yeah.
Oh, sorry. No, it's 200 seconds. 2 into 10 to the power 2, right?
It's 2 times 10 to the 0, which 10 to the 0 is 1. So it's 2 times 1. So that should be 2 seconds.
No, it's 2 times 10 to the power 20, right? We have 20 here.
Zach's right. It's 2 times.
It's just 0.
2 times 10 to the 0th power.
Yeah, the 0 is the power.
Okay.
All right. One other thing you can try, Deb. There's a button called Auto Scale in the lower left. Yeah, if you click that, what it'll do is automatically try to find the right amplitude range to display.
Yep. Yeah, and so you're using the Qt GUI sync. So each one of your tabs here, there's an equivalent standalone plot that you can also use, right? So like when you change that update rate, this is kind of why I had it backwards. When you change that update rate, that changed it for all of the displays. right? But if you just had a waterfall sync instead of the Qt GUI sync, right? Like if you go back to your GRC on the blocks on the right there in the search window. No, you don't have to open this. You can, yeah, just look on the right there. Just type in Qt. Right, so okay, so here you can see they have, you have the Qt GUI sync that's in there, but they also have frequency sync, constellation sync, number sync, I think frequency is the FFT, waterfall is the waterfall, right? So you can independently put all of those syncs in there, not all of them at once, right? And then you have individual control of each one of the displays, right? So that's something that I do a lot, especially with the FFT or the frequency sync, is the update rate is inverted on that one, which they're automatically correcting for in the Qt GUI sync in the code. So that's one that I normally do 0.01 for my update rate, and that gives me a really fast, kind of not quite real time, but closer to real time FFT display. And that's usually, I usually like that on the FFT display, but not so much on the waterfall display. So you can kind of independently control those things if you use individual displays. You can also have them displayed side by side rather than on tabs like in the Qt GUI sync. So anyway, these are all just kind of like tricks of GNU Radio. Nothing you necessarily absolutely need to keep moving with your project.
Okay. Thank you so much.
Yep.
Do you have any questions?
Actually, one more detail, especially if you're trying to take precision measurements. So see, go ahead and click on your UHD source. I noticed when it fires up, it says it's detected the Jackson Lab Firefly GPSDO. So down where you have clock source and time source, right? If you click on those drop downs.
Clock source, yeah?
Yeah, right there. See how it says OB GPSDO?
Yeah.
Click on that one, and then same thing for time source. So what this will do is it will actually pull from the GPS that's in the N210 for frequency and time references. Right, so that will do things like a very common problem with UHD if you don't do things like this is built-in frequency offset. Right? Or not built-in, but a native frequency offset that tends to occur. The equivalent when you work with like an RTL SDR, they'll tell you how to do like PPM calibrations, right? And the local oscillator will be slightly off from what you want. And it's most noticeable at higher frequencies, so this might not be as big a deal down at HF. But if you're trying to do things like the frequency measurement test, right, you'll want to make sure that you're selecting that onboard GPSDO to get the best possible frequency and time reference. Right, so yeah, you won't really notice a difference here, but that has actually locked in the frequency references. Like if you were to do a bunch of decimation and zoom in on the WWV carrier, right? In the old version, you might notice that it's slightly off from 10 megahertz. In this new version with onboard GPS reference, it should be dead on the 10 megahertz reference. Or dead on the 10 megahertz center frequency of WWE within whatever precision the GPS can supply. Right, so that's all. One more detail.
Thank you so much.
Yeah. Okay. I'm going to go ahead and probably actually drop off because I got to get on another call here in a few minutes. But like I said, if there's any other questions or anything like that, feel free to hit me up an email or on the list or whatever.
Thank you so much.
Yep.
Nathaniel, you have his email, right?
Yeah, here, I'll just put it in the chat again real quick. That's me. I'm also on the HamSCI mailing list. And I'm the one that's been emailing about the active antenna design. So you can find my email there as well. It's the same email address at all my university stuff.
Thank you, Jeff.
Yep. Yeah, no problem. I know how frustrating it can be just to make simple things happen with GNU Radio. There's power in GNU Radio, but there's also a learning curve. And it's sometimes a very silly learning curve, just because they don't always have the best tutorials and documentation out there. So don't feel bad trying to figure out even what you might consider simple. It's not always obvious in GNU Radio. Like that antenna drop-down thing. How come they have drop-down options where there isn't an option that's like none, right? How would you ever know that you could click on the field and delete it to leave it empty, right? Like they don't describe that really anywhere. So, but
Thank you
okay.
so much.
With that, I'm gonna go ahead and say goodbye, everybody. And I'll talk to you guys next time. Yeah, no problem.
Thanks a lot. That was really cool. I think I'm about ready to sign off too, to go get dinner with my family. But I did see we have some more DX online here. Steve, G4GXL, how are you?
Yeah, hi. I'm good. I thought I'd just drop in. First time that I've been in one of these chats. I'm quite new to Tangerine. Don't know most of you. I know Scotty. Haven't seen you a while, Scotty.
Hey, Steve. Yeah, it's been a long time since we talked.
Yeah. I think it was probably about 5 years ago at Dayton.
Yeah, at FTIM. Yeah.
Yeah.
Well, glad to talk to you. So glad to see you're still alive and kicking.
Yeah, well, I'm looking forward to see what you guys are going to produce. I've just got a Hermes Lite, so I'm sort of getting back into things.
Okay, good. Well, you need to come up with a talk and present something in DCC this year.
Yeah, see about that.
Well, anyway, you can come and listen anyway.
Okay, I'm gonna leave. Thank you, everybody. Okay, thank you, Tom. Thank you so much.
Thank you. I'm gonna say 7-3
Thank you,
as well. So
Nathan.
thank you so much.
Thank you, Nathaniel.
You're welcome.
I'm going to say 73 also, folks, but that was interesting. Thanks.